and stand in front of a mirror that does just that. And let's see, I am part of Windy City Lab, so I'm a subcontractor with Northwestern, and the lab is located at the Connectory, which is at the Mart. And I am now doing this work through CECSE, and that's, you know, hopefully as short as intro as I can do on me. So rules of the road, as we go through this, we are going to do a new professional development each Thursday at 4. And by the way, we start promptly at 4. Just a quickie, when I was in college, they can't do this anymore, I'm told, at least at Northwestern, but when I took a calculus class, the calculus teacher would literally close the door at the start of the class and lock it. And back in those days, there was no recording. So we're lucky here, all these sessions are recorded. If you miss it or you come in late, you know, these will all be available, hopefully within a couple hours on both YouTube and Vimeo. I encourage feedback and interaction throughout the workshop, and as we go through this, I'm going to try to pull that interaction from you guys as well. You will all start out muted, and we have Mia as a co-host who can make sure that, you know, if anybody's mute you so that everybody is, we're not disturbed by clanking, you know, household goods and so forth. But what I did want to let you know, because a lot of people I don't think know this, is if you want to say something, all you have to do is hold down the space key. And when you hold down the space key, it will unmute you. And so it's like a mic, right? You're clicking on the mic, and then you speak and we will hear you. And then when you let up on the space key, you'll no longer be audible and you'll be back muted again. So that's kind of a neat thing. You don't have to go down and click to the bottom left and say unmute and then forget to remute it. You just use the space key to do that. And also, if you prefer to use the chat window, go ahead and use the chat window. The chat window is a little difficult for me to see, even though I can, because it takes up a lot of space over what I'm trying to present, which you wouldn't see, but it's a little distracting for me. So Mia helping me out in watching the chat channel as well. Also, please use Slack for continuous communications outside of the PD workshop. The channel is Be a Swift Ninja, and I am watching that channel all the time, and feel free to ask questions there. The other thing is, if you ask questions in the Swift channel, other people can benefit from the answers there from that, as opposed to you emailing me. Email is fine, though, if you only want to do that. In the end, we may end early, but we will not finish late. So that's where we are. So let's start out with a little review. The first thing is, how many that are in attendance now saw last week's session? We get either a show of hands, or how does it look, Mia, as far as people?
We have 3, 4. We have Angel say he watched. Thanks for watching, Angel, but he didn't get a chance to attend. We had Joan, I believe Taria, and myself attended last week.
Okay, so anybody that didn't and would have no context, or we just have a few, or?
Well, we have our visitor, Julie.
Right,
and
okay.
We have someone whose screen name is Chicago CI Jam.
Okay, all right. So that's good that most people have seen it. So how many tried the homework? I did get some homework submissions. So those of you that did the submission, rock on. That's great.
I tried it.
You did it?
Yeah, I did it and I submitted it.
Yep. Okay, so we already talked about the recording. Were there any questions, just briefly, from last week? Anything on delegation or protocols that you saw that you still are confused about?
I have a quick question.
Sure.
Is it possible to pass a parameter within the protocol?
Yes, absolutely. Excellent. So in fact, we can even show that in what we're about to do. So let's work through the solution to the homework real quick. What I'm going to do is switch over to Xcode. Can everybody see my Xcode at this point? And hopefully the text is readable. So one of the things that I wanted to do is just highlight, because you know me, I don't like to do all this UI work in front of you, but I did want to highlight one thing. So if you're going to get the homework to work, actually, let me go to this. The homework was to improve the user experience by disabling and enabling the appropriate buttons using delegation, right? So essentially what we're doing is when we run this app, what I don't like is if I hit start here, the start button's still highlighted and I can continue to hit it and it's still enabled. If I hit the stop button and it's stopped, I can still hit the stop button again. And so what we want to do is clear that up. Now, to disable or enable a button, we have to be able to talk to it programmatically, which means we have to create two outlets, one for the start button and one for the stop button, so that we can refer to them. And that's the only UI from a storyboard to getting your outlets in. You will have to do that. You can't. You're going to use delegation as well, but that's going to be a necessity. So if we go to the stopwatch, the thought is that the stopwatch needs to tell us if it's running or not. And when we find out that information, we can then do something with the UI. And so one of the solutions that I have done is to say a function is running, and another one that is stopped. And what these functions would do is the stopwatch would call these functions when it is appropriate. So for example, down here in start, I would say delegate dot is running, and I would call that. So when start happens on the stopwatch, we call this is running function. And then correspondingly for stop, we would do delegate dot is stopped. So that would be the modification that you would do to the stopwatch, okay? Then if we go back to the view controller now, we come up here, we are going to get an error. Now, does anybody want to say why we're getting an error about does not conform to the protocol?
Because we didn't do the same thing that we did in the stopwatch flipped into the view controller.
Yes, so essentially we said here that we are going to conform to the protocol. By putting that in there, that's what we said. Well, if I come over here, the protocol has 3 functions in it. But over here, we only did one of them. So the nice thing about this little icon says I can fix this for you if I want. So I can click on that and say fix, and it will add in the 2 extra functions that we need to do. So now in here, we got to put the code in to actually do something. So if is running is called, what do I want to do to the start button? So if I do is enabled, which is the function that we're going to do to enable or disable it, if it is running, then we want to say start is enabled false. And the stop button, we want to make sure is enabled to be true. And then we just want to reverse that in this other function. So this will be true. This will be false. And then the only other thing we might do is when we first power up and we first start running, we're going to want to set the buttons a certain way. And so what I typically do is down in view did load, I want it to act like it's stopped, because when we first start out, that's the state we're going to be in. So I come down here and I put that in view did load. We go ahead and run. Let's see if I kind of doing this on the fly here. So good. So now when we run, we see the stop button's disabled. The start button's enabled. When I click on it, now the start button is disabled, stop is enabled. Now I can click on the stop and it works. And so that was the exercise. So that's how you would flip, adding some additional things into the protocol. Now, what Angel's asking, which I think is pretty cool, is, Kevin, why do this when we could say, you know, function running state, let's say is on, and then we could say, you know, off on bool, something like that. So we could just call a single function and then on the other side implement that based on that information and not have 2 different functions here, because we could do it with one function and then just pass parameters as a part of it. Okay, so any final questions on that? Okay, so moving right along, now let's jump into objects and inheritance. So the PD objectives, well, first of all, I want to really help get an understanding of the core concepts around object-oriented development and how it really differs from procedural development. Because what I think you will find, and what I've found in adult learners as well, is that people that have had some exposure to computer science typically will think about think about things in a very procedural way, and object orientation is just like flipping your brain inside out. And so that's what we're going to do today, is flip your brain inside out. And once you get a handle on this, then the next thing is there are specific relationships between objects, and one of them is inheritance and one of them is composition. And I'm going to give you a way to say it in a way that when you say it, you will know whether it's composition or inheritance. And again, in my experience, is a lot of times I will see people trying to create or compose an object made of other objects and use the wrong thing, use inheritance when they really needed composition, and vice versa. We're going to talk briefly about what a good object is, and we're also going to look at how you would override methods, and which is important in the whole hierarchy of inheritance. And then we're going to build a simple app using these techniques. So first, we'll start out with objects, what they are and what they're not. Then we'll go into creating objects. So we're going to do class declarations, instantiation, and instance, and understand how to do that and what those are. Then we'll jump into the relationships between objects, composition and inheritance, and then we'll implement these objects in Swift and do the code example. So here's where I want you guys to use the chat window, all of you, because all of you, independent of your background in Swift, will be able to do this part of the exercise. Is I want you to type in the chat window what you see. So these are icons from the Noun project. Thank you, Mia.
I'm sorry, Kevin, do you want me to tell you what people are typing in there?
Yeah, in one sec. So they're, I'm assuming they're close to correct. Some may not call it a lamp, they might call it a light or whatever, but plane, chair,
right
car,
yeah.
right, house or home, you know, my yacht or a boat. Yeah, thanks for checking me. I didn't really make that clear. But the goal is for you, all of you, to be typing these things out. Okay. So now you may not have all called it exactly the same thing, but I can bet without even looking, and I can bet my first month's salary, that all of you typed nouns.
That is true.
Mia, did I lose my first month's salary? Did anybody put in something other than a noun? Okay.
No, everyone's got it now.
Good. Okay, so that means that the one point that I wanted to make is objects are nouns. They're not verbs, they're not adjectives, they're nouns. Okay, so if you're wondering, is somebody thinking or creating an object in their code, or are they you know, developing something in an object-oriented way, when you're referring to an object, you better be using a noun. Otherwise, it's not an object. Okay, so what is not an object? So go ahead and type what you think is going on here. Okay, so I'm not going to bet on this one, but I'm hoping that most of you typed things that were actionable, actions, verbs, verb phrases. They were things that were happening. Okay, so it's jump rope, you know, you're cutting a ribbon. Hopefully you didn't say scissors. If you did, that would be a noun, but that wasn't the point here. So And this is not rocket, but it's a rocket blast off. So there's this this launch of a rocket. So the key thing here is these are all verbs. And so these are actions that you can do on objects or that objects do, but they're not objects themselves. So the whole point of this is you have verbs, which are actions, and then you have objects, which are nouns. So the reason I bring it up is because, for example, if you did, one of the computer science classes at CPS that uses Scratch as an example, which is over here on the right, you're going to be doing things in a very procedural way. So you're saying, okay, forever, move 10 steps to the right and then turn right and go 15 or turn right 15 degrees and then do that forever. So it's a procedural thing. On the left, we say, what's called a flow chart, right? And it has you do these different steps, make some decisions and so forth. And it's very procedural. I mean, we will talk about computer science in general and say, if you can write a recipe for how something is to be done, then you're practicing computer science. You're doing that, which you are. But what I want to get you out of is that in the procedural world, this flowchart is a first-class citizen, and we are going to demote it. Basically, we are saying you are no longer the first-class citizen. The object is the first-class citizen. So in this case, where we have lamp plugged in, is the bulb burned out? Plug in the lamp, replace the bulb, repair the lamp. Guess what? There's a bunch of nouns in there, and those nouns are the objects, and they become the first-class citizen in your design, not the procedures that you have or that you would see there on the left. So if we look at a more formal definition of an object, the object basically has three things. One, it has a noun, such as car in this case. And then in what I've written down here in the next section is make, model, and color. And so these would be thought of as adjectives. So these would be something that would describe or modify the car in some way. And then start engine, accelerate, apply brakes, these are all verbs. And so those are the actions that we can take on the object. So this is sort of looking at it from an English language perspective. If we want to look at it from a computer science perspective, every object has a name. The make, model, and color, those adjectives, we refer to them as properties or attributes. And then the verbs, the functions that we have there are referred to as methods. And those are the things that you'll see referenced in the Swift book. And so somebody says, what is a property of this object? I'm looking probably for an adjective of something related to the object itself. So if you watch the last one, I love metaphors. So here's the metaphor that I have for, drum roll please, for objects. So first of all, let's start out with a blueprint. So a blueprint is something that describes how to make something and how everything goes together, and it doesn't actually create the final implementation. But if somebody actually followed everything in the blueprint, whatever the blueprint was for, what should come out of it should work. And so when we think of this, let's say this is a blueprint for a house. So your general contractor with the electrician and the plumber are all going to follow this blueprint, and they're going to create a house. Well, the cool thing about this too is that the same blueprint can be used for multiple houses. So I can have a second house, a third house. In fact, I can make as many houses as I want from this same blueprint. And the blueprint in our metaphor relates to what is called a class in Swift. So literally, you could replace the word class with blueprint, and it would be even more correct, but it's not a keyword in Swift. You have to call it class, but class is a little more computer science-y. But my view is whenever anybody sees a class, they think of it like a blueprint. It's not the object itself, it's a blueprint for the object. And then here are all the things that we can define that class can do and will do as part of its blueprint. Now, when we create these houses here, the process of creating the house from the blueprint is referred to as instantiation. You'll hear the word instantiated. If you instantiate a class, you are creating an instance of that class. So for example, here where I say var my home equals home, that variable, that my home, is an instance. So I've now created a house simply by using the constructor on home. This is like calling the general contractor to read the blueprint and build your house, and you've got that. And of course, you could do one for a second home, and you could do one for a cottage. This would be a little odd that you would have a cottage, second home, and my home all built with the exact same blueprints, but you get the idea. So that's the metaphor for classes and objects. Now, it is the case that I will do this all the time, and other people will too. Everybody's going to refer to this as an object. It's not an object technically until it's instantiated, but we just refer to them as objects, the home objects, the animal object, whatever it is. So, but I think it's best to understand it in this form. So now when we look at a more formal definition of an object, we see that we have the class car, we have the properties here, the make and model. This is how you would define them. Here's the methods, here's how you define them there, and you have sort of that relationship. So in the lamp scenario, instead of having this procedural thing over here, we would literally create a class called lamp. And then we would say, you know, do we have attributes on this lamp that are the same types of things that they were asking questions here? And actions, they're saying, hey, replace the bulb, plug in the lamp. Do we have those functions, or do we have those methods there? And by the way, here's where we actually create the instance of this lamp blueprint with our lamp. And so instead of writing all this procedural stuff, you're constantly focused on doing objects and having your operations and your methods and attributes associated with the object. Once you kind of get your head wrapped around that, it almost becomes second nature. You almost can't think any other way than thinking about objects. And so when you, in your classroom, if you're saying, okay, we're going to do an app that does, request rides, let's say, well, there's a driver, and there's a car, and there's a route, and there's a schedule, and there's availability, and all of those things that I said, except for availability, are all nouns that are basically objects. And those are the things that you start out with first. So now let's talk about relationships between objects. So first of all, composition. So composition is what I call the has-a relationship. And let's take an example of a car. A car is actually made up of, this is a subset, obviously, engine, speedometer, wheels, steering wheel, and doors. And the key thing here is if I say a car has a speedometer, that's correct. That sounds right. Okay, and you'll see why that's important in a minute. But the has-a relationship means composition. And when you have composition, you are not doing inheritance. I repeat, if you're doing composition, you're not doing inheritance. So you don't want to see inheritance up at the top as part of the implementation when they really meant it to be a compositional thing. So doors, if we go a little farther, doors are made up of a keyhole, a window, a handle. And again, we have this has-a relationship, and this is all composition. So how does composition look in code? So essentially, we would create a class car, and in this class, we know that we have an engine, and we only have one engine. So therefore, there's only one variable here for engine, and then assume that we have these other classes defined somewhere else. Doors, we actually have a door class, and this happens to be the way we've defined our car class, is that it's just a two-door car. And wheels, it has an array of wheels, and it happens to have 4 wheels, thank goodness. And then it has a steering wheel and a speedometer. So this is how you would do composition on the car object or the car class, is just by putting all of these things as properties, if you will, into into your class. So inheritance is an is-a relationship. And so the way you want to think about ISA is let's start out with animal. And a cat is an animal, is an animal. So let's avoid the English of a and an. Is there an English teacher on I'll be in trouble with? But yeah, so cat is an animal and a dog is an animal. So this means that if I can say that, it means that they inherit from this parent class here. And what does inherit mean? Well, for the sake of just discussion, if we say that an animal basically has an attribute of it is air breathing, I'll just make that up. It breathes oxygen. So what it means is that if I declare a cat, which is an animal, then by definition, the cat breathes air. Okay, that is going to translate down to it as well as to the dog. So we can continue this inheritance hierarchy. We can say there are domestic cats. And so a domestic cat is a cat and it is an animal. And we can also say a lion is a cat, which is an animal. And we can do the same thing for mutt and for wolf as an example. So in this case, if there's any additional attributes, so what happens is we have some attributes here for animal, they're inherited. So the cat gets all the stuff that animals get. But then the cat might add some additional things. Let's say it has sharp claws. Okay, not all animals have sharp claws. So a cat has sharp claws, then it implies that a domestic cat and a lion are all going to have sharp claws as well. Okay, and the cool thing from a computer science perspective is if we implement something, if we implement an animal class, then when I declare a cat class, I don't have to re-implement all the stuff in animal. I get it for free. I get all that implementation. So like when you're creating your view controller, I see your hand raised, Angel. But I can't hear you.
I have a quick question. Is it almost like kind of like declaring a constant? Is that like kind of like where you're saying that the cats all have sharp nails, I guess, in a sense?
So if it's not necessarily like a constant, but think of it as just it's more like a replication. It's that the fact is that if a cat has sharp claws, then when I create the lion, I don't have to worry about creating sharp claws anymore. I just get it for free.
Okay.
So to make it even simpler, let's say the cat had a function called add. I mean, that's stupid, but let's just say it had a function called add. When I create a lion and I say it is a cat, I'm going to get an add function for free, whatever that was. Okay, so all of those just translate down the hierarchy. Now, it is the case that you can, and then every time you inherit, you can add new things, and you can also take away things. So you're not forced to have to inherit everything. Okay, good question.
Thank you.
So inheritance in code looks like this. You start out with class animal as an example from what we just did, and then we say class cat colon animal. So whatever class is right after this colon, this is what you're inheriting from. And you'll remember in the previous PD, we had UI view controller, comma, and then we inherited from the stopwatch delegate. That wasn't inheritance. In fact, I just misspoke by saying we inherited from it. We didn't inherit from it. We were just saying that we were adopting and conforming to that protocol. So that's a different thing. That's something different. This is saying we're inheriting. The other thing to keep in mind, some languages allow multiple inheritance, which means that you could inherit from an animal, you could inherit from, I don't know, a planet, and you could inherit from all these things, and they all get combined into one huge inheritance. Swift does not support that. You can only inherit from one class, and only one class. But you can have the chain keep going. So a dog can inherit from animal, that's fine here, and then the lion inherits from the cat, and the cat inherits from animal, and there's animal. So just to briefly ask, which you can put in the chat room, is the are the capabilities that provided by animal available to lion if it's not inheriting from animal directly? You just do yes or no, I think, and we can see, or you can do it in chat. What are you seeing, Mia?
So we have split.
Okay.
Yes and no.
Okay. So the answer is yes. Lion inherits from cat, so it gets all the capabilities that cat gets. But remember, cat inherited from animal, so it's getting all the capabilities that animal gets. So essentially, as you go down this ancestral tree, you keep globbing on additional things again and again and again. And when we get into next week's topic of classes versus structs, you'll find out why I'm saying this is wonderful. And then next week, we're going to talk about how terrible that is and why you want to use structs instead. So it's the nature of computers. So that's how we do inheritance in code. So just another example, here's a vehicle, a vehicle, so a car, excuse me, is a vehicle, a sports car is a car, hatchback, and so forth. So you get the idea behind the inheritance hierarchy. Now, the other term that I want to just throw out there, because you will see this all over the place, is what is called a superclass and a subclass. So what this means is that if car inherits from vehicle, the car is a subclass. If superclass is vehicle. But if we go down a level, it's all relative. So here, the sports car is a subclass to car. Car is a superclass to the sports car. But it's a subclass to its, so whoever it inherits from, that's the superclass, and then it itself is considered the subclass. Whoops, sorry.
Hey, Kevin, question.
Yep.
As it relates to superclass and subclass, is that relationship only in comparison to two objects or two nouns?
So good question. So this subclass to this superclass, this subclass will only ever have one superclass. It'll only be, that's a one-to-one. But this could be two different subclasses with the same superclass. Yep.
Thanks.
Mm-hmm. And the reason you can only ever have one superclass is because you can only ever inherit from one class. You do not have multiple inheritance in Swift. Okay, now we're going to talk briefly about good objects. So good objects are objects that incorporate encapsulation and information hiding. And it's just like, what the heck does that all mean? So I came up with this, which I think is, I think this will get the point across. So here's a Denon receiver. And this Denon receiver, the way you want to use it is you have knobs here for volume and changing function, and you can hit various buttons here to do certain things. And you interface with this object, this receiver, and you have this really nice, beautiful interface to do that. But when we look inside, this is what it looks like inside. Inside this receiver is a lot of complexity and, frankly, probably some dangerous electronics that you could put your hand in and electrocute yourself. So the key here is I wouldn't want to have a receiver in my house where to operate it, I had to understand the inner workings of this receiver. There's a lot of complexity here. There's a lot of engineering, a lot of design, but what they did is they made your interface, what you use, to be just this front panel. So that's information hiding and encapsulation. That's a good object. So when you see somebody creating an object and they have properties everywhere and functions everywhere and they have all this stuff going on and they're visible to anybody else, that's not a good object. Those are, it may work, but it can be a source of problems down the road. So what you want to do is you want to have as minimal an interface that somebody can see and then hide all your complexity inside the object itself. So we've talked about a lot of objects in the real world. I did just want to name some objects that are in UIKit, which will probably be somewhat obvious, but let's look at, for example, the UI view controller. I mean, that's one of the most popular classes that you will use in your app development. It's a noun. and it has methods that you can do onto it, and it has properties. A table view, that's another one. That's an object, and it has methods, sort of insert rows, move row, or you can ask if you're in editing mode, so it has attributes. A button, that's an object. A label, that's an object, and these all have methods and properties. So you're going to see these everywhere in iOS. Okay, so with that, we have about 20 minutes left. Let's write some code. So what we're going to do is we're going to implement a little app that follows this inheritance hierarchy. So if I run this little video, you're going to see this is my favorite animal names app. And what happens is you type a name in, and notice the segment control at the top. We have selected whether it's a dog or it's a lion or a cat. And when we type in the name and we hit add, then in the table view down here, a icon comes up representing the category of animal it was. Is it a cat? Is it a dog? Was it a lion? And then it says the name that I put in here, but it also says that they say something. So a cat will say meow, and a dog will say woof, and like that imitation. And then the lion will roar, right? So we're going to implement this app using inheritance and see, and also do some method overrides so we can see how cool this is. Okay. So we're going to start out with an app that's already got the basic view controller. If I just look at the storyboard briefly, you'll see I've got the segment control up here, I've got the text field, I've got the add button, and I've got the table view here. So in the view controller, we also have a IB action to the segment tapped, which we actually don't use, but we do use the segment control to see what state it's in. And then we have the add button tapped. So this is going to get called anytime the add button is hit. And then down here for the view controller, for the answering to the delegation of the UI table view delegate and data source, we always have the two required things for table views: number of rows in section and cell for row at index path. So let's start out. And if I go back to this, and I look at my objects, I'm going to say, well, you know, to start this, I'm thinking I'm going to need to create a class for these various objects. And I'm going to start with the root. So I'll start with class animal. And the animal is going to have an attribute, which is the name for that type of animal. So it's going to be the name that we're giving it when we ran the app. So, oh, never mind. It's going to go through the animation again. So we're going to do var name : string. So we're going to say every animal has an attribute called name. And then, just as a little kicker here, a little one up or level up for doing this, you could do this. And then once you've instantiated animal, you could set name to a value. But you're always dealing with optionals in that case. What I'm going to do is say, you know what, you cannot declare an animal without giving it a name by law. So what we do is we say init, and we say name : string. And then we do self.name, which refers to this name here, equals name. And when we do that, we see that the error goes away. And the reason it goes away is this is no longer optional. Because constructor here, we're guaranteed to always give it a name. It can't ever not have a name. And so that's a really safe way to do that. So what we've done is we've created a class called animal. And then down here, let's see, in our add button, well, before we do that, if we look at our table view is really going to be a collection of animals. So does anybody have an idea what we need to add in our view controller to support a collection of animals? And you can use the mic if you want, if you just want to hold down the space.
Stack view.
Not a stack, good guess, but not a stack view. So this is at the model, this is at the level where, so we've already got the UI done. So if we did a stack view, we'd be modifying the UI. The table view is already there. The table view is going to be a list of animals. So how do we represent a list of animals in Swift?
An array?
Yes, exactly, an array. So we're going to say var animals equals animals, or animal, it's an array like this. So what this does is this creates an animals array where every element of the array is an animal, and creates that as an empty to start. So down here in the table view, as soon as I've done that, my thought is to go down here and change this. The number of rows in section is the thing that it's going to call to know how many rows we have. Well, how many rows do we have? It depends on how many elements we have in the array. So this is going to be animals.count. So right now it'll be 0, but as we add them, then the count will go up in the array, and that's how the table knows how many are in there. And when we add a button, we do an add button tap, we're going to need to add an animal into the system. So we can say animals.append, which is appending into the array. And then if we wanted to create a new element of animal, what would I type here? Anybody want to throw out how to construct an animal or instantiate an animal? So essentially, you would just type animal. So that's the class animal. So I'm now doing an open paren to create the constructor. And notice it's telling me, hey, you need to give it a name.
Okay.
So I can say name.
Would you just name it after every, I guess, category that we have?
You could. So one of the things that I try not to do when I develop is I do little baby steps and then see if it works, do another couple baby steps, see if it works. So I always try to teach, start with something simple that works and then build on it. So right now, this is not the final implementation, but what I'm trying to do is just test to see if I add an animal in here and I've got the array and the count is going up and I actually show something here, let's run it and see if we see anything. And then we can go back and sort of refine it and make it a little better. So in this case, I'm going to just give it a name called test because I'm just testing right now. And then down here in the self-arrowed index path, there's two things I always like to do. One is always grab the specific element of the array first. Then use it throughout all of your code in here. It'll simplify things in the long run. So we can say, let animal equal animals index path dot row. So now what we've done is we've gotten the animal, and of course it's complaining because I haven't used it yet. So, when Xcode first started doing this, it made me code like really fast because I wanted to code fast enough so that it didn't give me an error because it really made me feel bad. And now I don't care. So it's ahead of me. But it's right. It's saying you declared animal, but you haven't used it. So let's use it. So what we're going to do is say cell.textLabel.text equals animal dot, and notice we get name because that was on there. So now if we run this, let's see what happens. We haven't gotten to inheritance yet, but we're going to in the next step. So I'm not going to enter anything here because we don't use it yet. But if I hit add, notice, boom, boom, boom. Every time I hit add, I get something new in the table. So before we get really fancy with anything, we just check the basic functionality. Does this thing work as far as the table is concerned? And it is. So the next thing we want to do is probably go add in these other classes. So again, remember that we're here and this is the functionality that we want. So we have an animal, a cat, a lion, and a dog. So we're going to go over here. We're going to say class dog. And notice it says super class. That's animal. And we don't have to add any code because we're going to inherit everything from the first one. So let's do class lion. or cat is also an animal. And then finally, we'll do class lion. And then what do we put here? Do we put animal or cat?
People in the chat are saying cat.
Exactly, cat. If you said animal, it would sort of work, but you wouldn't get the if you add any functionality here for cat, then you're not going to see it when you have the lion. Okay, so we have dog, cat, and lion. And now what we want to do is when that add button is tapped, it's going to be based on which segment control is set as to whether it's adding a cat, adding a dog, or adding a lion. So the way I would suggest we do that is use a switch statement, and we're going to reference the segment control, and it is selected segment index, and the first is going to be a 0. And in the 0 instance, so when it's 0, this means the cat is selected, so it means we want to add a cat. So if we want to add a cat, we do animals.append. And now instead of adding an animal, though, we're going to add a cat. So we're going to say cat, open paren, name. And then where is it going to get the name? Well, when you're up here, you're typing the name in here. And that's in the text field. And we have the text field right here. So I can just say text field dot name. Sorry, text field dot text. So that's the attribute on text field. Now, because this is an optional, it won't let you pass an optional into name because we said they were required. So we're going to let it correct it by doing this fix, which means we have to give it a value should it not be set. So I'm going to do this and just say none. It's never going to use this, but we need this for Swift. So now we've taken care of the 0 case. So if we want to do the other 2, we're just going to copy and paste. Copy and paste. One of the things kids learn is totally good in software development. So we've got cat, we've got dog, and I believe the third one was lion. Okay. And then this one, we'll just say do nothing on the default. Now, if I compile this, the build succeeded. And here's the big aha. It's animals. It says here it's an array of animal class. It doesn't say it's an array of cat class or dog class or lion class. It's an array of animals. Yet, it allowed us to add it into the array. It's letting us put cat, dog, and lion in there. Why is it doing that? Well, because they all inherit from animal eventually. So therefore, they are legally allowed. So for example, if I were to come up here though, and let's just for this, to show this off, if I say class spider, and in my world, those aren't animals, they're just evil. So we have the class spider. Now, let's suppose I want to add in the spider. So I'm going to go over here, take all this out because that class didn't have a constructor. And I'm going to say spider. I'm going to put a spider in there. Nope, won't allow it because it doesn't inherit from animal. So we're going to take that out and love the fact that this is happening. Okay, so we can put all the cats and dogs and lions and tigers and bears, oh my, we can put them all in the same animals array. And then down here now we're going to want to look at what's there to determine what to show. So in my case, what we're going to do is do an if, and I'm going to show you how to tell.
Kevin, I'm sorry to interrupt. We got a question before you move on.
Sure.
From Angel.
I have a question. Can you do multiple inheritance within cases?
Within cases?
Yeah. So like, could there be a multiple inheritance for with an animals and then like an insects for spiders?
So they would all have for them to be appended into the array, they all have to go back to one root class.
Okay.
Yep. They can't, you can't just have, if you wanted to just throw anything in there, there is something called any. But you want to avoid that because that's, basically that's not good programming practice to do that. You want the language to help support you with putting things in that you shouldn't be. So yeah, great question.
So then if you wanted to do an NSEX class, you would do a case 3 and then start doing your NSEX?
Right, but you would need a different array, or you would have to have animal would have to also inherit from some base thing called living being or something like that, and then this array would have to be living being if you wanted to get them all in there.
Yeah.
Yeah. Mm-hmm.
Okay. Thank you.
Okay. Yep. So we've got about 5 minutes left. What I want to do is just do one thing with how you check the actual type. So what is happening here now is when an animal is picked from the index path, it's an animal, but it's going to be a cat or a dog or whatever. So we're going to say if animal is cat, then what we want to do is say cell.imageView .image is going to equal UI image named cat. And the reason this works is because over here in the assets, I have cat, dog, and lion already in the assets directory. So we're saying that, so let's see. If animal, not animals, there we go. Okay, so if we do that, then we can take this and we can do dog. Let's do dog. And then I'm going to give you another aha thing, and then we're going to have to finish up. But what we're going to do now is run this. If I type in Tiffany and I hit add, so there's Tiffany, and we ended up with a cat here. I don't know why I got a second one. Oh, because over in our code here, we left this append here with test.
Yeah, we still left it in the code.
Exactly. So it did two things. So let's take that out because that's annoying. Run this again. And I'm not going to worry about the name. I'm going to just add. So it put a cat in. Now, if we do dog, it should put a dog. Oh, it put a cat. So why is that? Because we didn't change this to dog, because I'm going really fast trying to finish this. So we are now to dog. Let's go try dog and add, cat and add. I'm going to add lion.
You didn't add it.
I didn't add it, but guess what happened? A lion is a cat. Remember? A dog is not a cat, but a lion is a cat, so this still worked. So what we want to do is just at the end of this, we definitely want to add the lion in. So we say lion. And we go lion here. And we are now, I believe you will get cat, dog, and lion. And you get the lion. So we don't, unfortunately, we have 2 minutes left and we don't have time to finish the code. There's one more piece of code that I wanted to show, which I will put in the project, and I'll do an addendum video that I'll just put out that will cover this last step. And then it'll allow you guys to kind of go through the homework. But let's jump over to any questions, I guess, real quick before we wrap up.
Where would I get the homework at? On the Slack site?
Yeah, and I'm going to give it to you right here. So basically what it is your homework will be to implement what I just did to start with. And then you'll refactor the code so that when you choose an image, you want to use inheritance and overriding of methods. I did not have time to show you overriding of methods, but I will show you that in an addendum video that I'll put out before, and I think it'll be, you know, pretty obvious then what to do there. So yeah, sorry I ran a little long on that, but you know, I will learn as I go along, so.
Thank you so much.
Thank you.
All right. Thanks, everyone. We'll follow up in Slack and email with the video,
Exactly.
slide deck, and the project. Thanks again, Kevin.
My pleasure. Take care, guys.
Thanks. Bye.
Bye-bye.